Welcome back to Network Information Hiding, the online class. Today I will discuss part A of chapter 10, which is about steganography in the Internet of Things or in cyber-physical systems. When I started my research in 2011 and 12 on CPS steganography, I was not sure whether this was actually a good idea, and however, I conducted the research. And one of my first ideas was back then to analyze whether it's possible to have covert and side channels in smart buildings or building automation systems would be the more appropriate term, as smart is more a buzzword and usually buildings are not that smart. If you have some kind of a CPS or IoT system, then you can have covert channels that allow you to exfiltrate data. For instance, in many organizations, it's that an industrial control system or a building automation system has some less secured uplink or remote access link that can be used more easily for exfiltrating data. So if you can use the network protocols in such a CPS, then you can rather easily bypass more advanced filter technology such as deep packet inspection or some anti-covert channel methods that are applied to the TCP/IP network. And such communication protocols are often embedded in UDP payload, but they contain like an own protocol stack, like in case of the BACnet protocol or the KNX protocol. And for side channels, it's an unintentional sending. So you do not exfiltrate data by intention, but you leak data unintentionally. For instance, if it's possible to observe in a policy-breaking manner physical events, for instance, if an employee monitors his boss, then using temperature sensors or humidity sensors or presence sensors or actuator states, like if the light is turned on, some things like that, then that would be a policy breaking channel if the policy foresees that this is not allowed. Also, another scenario would be to plan some theft and study when someone is home, things like that. So in the paper that I linked below, I explained to the best of my knowledge for the first time, because I just did not find any work that deals with this topic before, how, especially for building automation CPS, one can prevent that. And I introduced a so-called building automation, a building aware active warden that has a database of all users, their roles. It can be even a multi-level security system, but it can also use other access control mechanisms like role-based access control, things like that. And different users can only access the automation equipment, whether it's in the building or remote, or whether it's an IoT sensor or whatever it is, only through the unified API over the warden. It's like a middleware. And so, like shown here below, you can have different applications that are used by different users. And you have some hardware abstraction, and the building aware active warden decides whether you can access certain device in a reading or writing fashion. Whether you, depending on multi-level security setups, it's different to categorize whether you read or write something. I don't want to go into all the details here, but it's a mechanism that works pretty well if you have some typical hierarchy in an organizational structure, because then you can apply the organigram to the security policies, or in other words, you can map that. So later I wanted to study with my colleagues in this paper, also 2012. I think it was in November, while the first one was in August, presented in Canada, and this one in Besançon in France. How this data leakage works. In this case, you can replace BAS, what means building automation system, with any other network, inter-network connected cyber-physical system or IoT component. And so you have some sensor and you want to leak it over the internet. And what you can do is you just modify, for instance, in an using all the different techniques that I explained in the previous chapters, the traffic. And this is a typical scenario because let's assume it's a smart building or building automation system. Then this is a location 1 of the company and this is location 2 of the company. And you can control buildings remotely using building automation protocols that are carried over, for instance, UDP or TCP. And a passive observer can then read data that is exfiltrated in unused fields, for instance, of these protocols. So in comparison to the previous work, this is a network-specific work. And this is a common setup that we also discuss in our book in chapter 7. So basically you have this covert channel here. And if you have a side channel and you have multi-level security, and let's assume this is a confidential sensor and this is a public network, then you can apply multi-level secure routing with a filter so that, for instance, if this sensor wants to communicate with a public device, then this is forbidden, at least if the sensor value is written to that public device. And you can also say, okay, let's assume this sensor data is read by a top secret level floor controller, then the communication would be allowed. And however, only data that flows in a policy conforming way can be observed. Of course, a man in the middle can still read it if it's unencrypted, but using a good routing strategy, the data would be routed around a network link that is easily observable, as we did it here with the so-called BFR, the Backnet Firewall Router. That's an open source software for the Backnet protocol, which is the Building Automation Control Networks protocol that can be embedded in UDP and then is called Backnet IP. So let's assume this is a top secret domain here, and this is a secret domain. So we can configure that, for instance, top secret level data is not, values are not sent to secret level data. And or that secret level devices cannot read the temperature from a top secret level temperature sensor. But such a device here can also not turn on the heating on a secret level device. So you can map these policies, and for every floor and every room you can have your own router if you want, and in the end there's a central router. In our testbed setup, this was of course not redundant, and it was just a proof of concept, but it works, and it can be easily done with such software. And if you extend multi-level security or use another model like role-based access control, you can apply this to normal organizations. So while my own work was limited to middleware solutions and building automation protocols, especially the Backnet protocol, which is one of the most popular building automation protocols in the whole world, with more than 1,000 registered vendors, there are also other IoT and CPS protocols such as CoAP and MQTT. There's quite a lot of work. I just cite 2 papers here that was published during the recent years by Mileva et al. In paper number 2, I'm also a co-author. And if you are interested in IoT protocol steganography, then should have a look into these papers. So for now, this is all about how we can transfer and exfiltrate and exploit side channels in building automation and CPS in general and IoT systems and environments, but well, steganography is about something more. You might remember the dead drops, where we store data in network caches. I think I discussed this in chapter 4. Well, this also works for cyber-physical systems, but in a different manner. And in chapter 10b, which is a conference talk I gave in 2017, I will show you how data can be secretly stored in unused registers of CPS devices and in actuator states of CPS devices.